if you go to America on a hot summer day, many people like to drink lemonade. One of the reasons is because anyone can make lemonade by combining water, sugar, and lemon juice. So this is a recipe for lemonade. For 10 cups of lemonade, you put together 8 cups of water, 2 cups of lemon juice, and 2.5 cups of sugar. Actually, for those of you who are thinking about the mathematics, maybe you're wondering, how can that be? 8 plus 2 plus 2.5 is 12.5 cups. Well, the reason is because when you add the sugar, it dissolves. And so it doesn't add a very large amount to the volume. So we call this about 10 cups of lemonade. Now, suppose you have 9 cups of water, not 8. And suppose you have 3 cups of lemon juice and 3 cups of sugar. How many cups of lemonade can you make? If you just tried to mix everything together, 9 cups of water, 3 cups lemon juice, 3 cups sugar, you will have something to drink. But it's not clear whether that thing will be tasty. So this is a problem which actually blends some ideas of chemistry, chemical reaction theory, together with mathematics. And it's actually an example of a type of question that appeared on AMC 8. This is a limiting reactant problem, or a question of saying, yes, I have 9 cups of water, 3 cups of lemon juice, and 3 cups of sugar, but maybe I can't use all of it because I need to keep the same ratio. So let's write down what the ratio that you need is. You need to have this ratio, which is 8 cups of water. You need to have 2 cups of lemon juice and 2.5 cups of sugar. I do want to say, especially if you're doing any problem about cooking or recipes, usually you have to be very careful about the units, because sometimes the recipes in English problems are not just in liters and milliliters, but in strange things like cups and teaspoons and tablespoons. But in this case, everything in the whole problem is cups, 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 cups. So I don't need to worry about the units. I'll just have cups at the end. Now, this is the ratio I need. What do I actually have? I have 9 cups of water, 3 cups of lemon juice, and 3 cups of sugar. I'm going to try to do this question in a way which I feel is a very safe way to do it, and also quite quick. The way I usually think about this is, if I was going to try to use what I have, what is the factor that I scale by, that I multiply by, to get what I actually have? So what I'm going to write here is that to get to what I have, what is the scale factor? This is like what I multiply by. I would scale by times 9 over 8. So I would, if I wanted to use 9 cups of water in my original recipe, I would take my original recipe and multiply it up by 9 over 8. If I was going to use my original recipe, but use 3 cups of lemon juice, then I would scale the whole original recipe by 3 over 2. Okay? What this row means is, if the only thing I was going to care about is this thing, the lemon, then how much more lemon do I have than the original recipe? That's what I scale by. Sugar, I will multiply by 3 divided by 2.5. I'll simplify these later. But when you look at this, if you're thinking about it this way, what you say is that if I was going to use these water, lemon, and sugar, these are the scale factors I need. But because I'm not allowed to use more of something than I already have of it, the amount that I can scale the recipe by is by the smallest of these 3 numbers. Because when I scale by the smallest of these 3 numbers, then I'll use up all of that type, all of that thing, and I won't use up all of the other 2 things. So what I care about is, in these 3 things, I'm asking myself the question, what is the smallest out of these 3 numbers? So now let's start talking about how you find out what the smallest one is. You could start to convert each of them to decimals. You could start to compare the fractions. But I'll give a tip. If you are doing a check of smallest, if I ever find something that's bigger than something else, then I don't need to worry about it. In particular, right here I have two things, 3 divided by something, 3 divided by something else. These are very easy to compare. Which of these two is smaller? Well, I have 3 divided by 2, or 3 divided by more than 2. If you divide by more stuff, you get smaller. So if I'm asking for what is the smallest, this one here is not the smallest because here's something that's smaller than it. And so now all I need to do is to compare these two. Which is smaller, 9 over 8 or 3 over 2.5? Here, I actually don't recommend that you always just divide the fractions. Dividing is actually very difficult. Whenever I'm comparing two things, it's easier to multiply. So the way that you often remember how to do this is to cross-multiply. Let me explain why that works. If I'm comparing these two things, really what I want to do is, if whichever of those two is smaller, it's actually easier to think about which of the two is smaller. I'll write is the same answer as if I take each of these two fractions and I multiply each of those two fractions by, I'll write 9 over 8 times 8 times 2.5. This is 3 over 2.5 times 8 times 2.5. You see, of course it's the same answer, because all I had is the same two numbers before scaled by the same thing. So which is the smaller is still the same, smaller. So these two will have the same answer. But the beauty of this is that when I do this multiplication, these 8's cancel and these 2.5's cancel. So actually this thing that I'm checking here is just 9 times 2.5 compared against 3 times 8. This is actually why most people, when you do this fast, what you say is if I'm comparing two fractions, I just cross-multiply. I take this 8 times the 3, and I take the 2.5 times the 9, and I multiply from bottom to top. And then I put the new numbers here, and I compare those two numbers instead. But I just showed you why cross-multiplying works. I showed this to you because if you ever have negative numbers, actually you then need to be careful. And so it's better to just understand why it works than to just always do the same thing. Okay. Now how do I finish this? 9 times 2.5, 3 times 8. I'm going to share with you how I would do this. I'll show you two ways of doing this. One way is to say I don't really like multiplying big numbers, 9 and 2.5. So I can say that the answer is the same as if I scale again by multiplying both sides by 2. So it'll actually be the same as, this is still the same as, if I multiply this by 2, I only have 9 times 5. Multiply this by 2, then I have 3 times 8 times 2. These, to me, are easier. 9 times 5 is 45. And 3 times 8 times 2 is 24 times 2, which is our friend 48. 48 appears very often when I multiply small integers. Which is bigger? 48 is bigger. And so I know that when I compare these, this is bigger, and so they all have the same answer. And so 3 over 2.5 was bigger in the first place. I want to share another way that actually one can think about this. When you're doing 9 times 2.5, if you forget about the point, 9 times 25, 25 is a very nice number because 4 of them make 100. So actually, if I do 9 times 2.5, every 4 of the 2.5s makes 10. And so I'll get 10, and another 10, and an extra 2.5. So I get, if I do this, I will get 22.5, and here I get 24. Two ways of seeing the same thing. I'm showing all of this because actually if I do this kind of a problem, these are all the thoughts that are going in my head while I'm doing it, and that's how I make sure I don't make mistakes. So I check at the very end, and I also have lots of intermediate checking as I do every problem. Okay, but now let's finish everything. So I now know that 9 over 8 is the smaller of these two. That's not the smallest. So the very smallest of the whole bunch is this 9 over 8. And so now we are basically done. What this means is that I can take my original recipe, multiply by 9 over 8. And so the answer is 9. Well, no. Always read the question again. How many cups of lemonade can you make? My original recipe makes 10 cups of lemonade. So if my original recipe is making 10 cups of lemonade, and I can scale the recipe by a factor of 9 over 8, then my answer is 10 times 9 over 8. If you wanted it as a fraction, I could just do it right here and it would be done. You can actually also give it as a decimal, because in this case we have decimals everywhere. Perhaps the easiest way to think of this as a decimal is that 9 over 8 is the same as 1.125. 1/8 is 0.125. I did this because I like to multiply decimals by 10. Multiply by 10 means I just push this over to here. So then when I multiply this together, I get 11.25 cups of lemonade that you can make with this recipe. And so this shows how you can think about these sorts of problems, which are actually really chemistry reaction problems, in a way where as you're doing all of the calculations, you're also able to check intermediate steps in them to help make sure that there are no mistakes.